Welcome students. Today's module comes under the course Microprocessors and Microcontrollers. The unit is Introduction to Embedded Systems and the module is Classification of Embedded Systems. I am Dr. Sulakshana Venekar, Associate Professor at JVM's GGPR College of Commerce and Economics, Ponda, Goa. So in this module, we are going to see just an introduction to what are embedded systems, and next we will be covering the classification of embedded systems based on different criteria. After going through this module, a student will be able to understand and explain the types of embedded systems based on the criteria used for its classification. So first we'll see what is meant by the word embedded. So embedded means something that is integrated within or attached to another thing. So an embedded system is a system that is designed by combining computer hardware and software to perform a specific function. So it is a dedicated computer system which is developed to perform certain specific tasks. And since embedded systems are designed to perform certain specific tasks, the system is optimized to perform very efficiently. Embedded systems have a close control over the hardware using a type of software called as the firmware. And generally, assembly language is most often used to develop the firmware since it provides direct control over specific hardware components. Next, we see the classification of embedded systems. Now, embedded systems are classified based on different criteria. So, first is based on the generation, based on complexity and performance requirements, based on deterministic behavior, and based on triggering. So we will see all of this criteria one by one. So first, we'll see classification of embedded systems based on generation. So first we have the first generation embedded systems which were built around 8-bit microprocessors like the 8085 XZ80 and 4-bit microcontrollers. Applications developed using the first generation embedded systems. Examples are stepper motor control units, digital telephone keypads, etc. The second generation of embedded systems were built around 16-bit microprocessors and 8 or 16-bit microcontrollers following the first generation embedded systems. These systems were generally used for applications like SCADA, that is supervisory control and data acquisition in industrial processes, then in data acquisition systems, etc. The third generation of embedded systems were built around high performance 16 or 32-bit microprocessors or microcontrollers. Then application specific instruction set processors like digital signal processors and application specific integrated circuits. The instruction set of the third generation embedded system is complex and very powerful. Applications developed in the third generation were in robotics, industrial process control, networking, etc. The fourth generation of embedded systems were built around system on chips, reconfigurable processors, and multi-core processors. These systems bring high performance, tight integration, and miniaturization into the embedded device market. Example are smartphone devices. Next, criteria on which the embedded systems are classified are based on complexity and performance. So, first is small scale systems. So, these embedded systems are built around low performance and low cost 8 or 16-bit microprocessors or microcontrollers and are suitable for simple applications and in applications where the performance is not time critical. These systems may or may not contain an operating system. In the case of The second type, that is the medium scale embedded systems. These systems are built to give around medium performance and are designed using low cost 16 or 32-bit microprocessors or microcontrollers or digital signal processors. As compared to the small scale embedded systems, these are slightly complex in both hardware and firmware and may contain an operating system. The third type is the large scale or complex embedded systems. So these systems are built around high performance 32 or 64-bit RISC processors or controllers, multi-core processors and PLD. These require complex hardware and software, and the system may contain multiple processors or controllers and co-units or hardware accelerators for offloading the processing requirements from the main processor. It contains real-time operating systems for scheduling, prioritization, and management. The third classification of embedded system is based on deterministic behavior. These are applicable for real-time systems. The application or task execution behavior for an embedded system can be either deterministic or non-deterministic. And these are again classified into two types: the soft real-time systems. In the case of soft real-time systems, missing a deadline may not be very critical and can be tolerated up to a certain degree. The second type is hard real-time systems, where missing a program or task execution time deadline can have huge consequences like financial loss, human loss of life, etc. The last type of classification is based on the type of triggering used. So these systems are classified into two types: event triggered, where activities within the system are dynamic and depend upon occurrence of different events. And the second type is time triggered, where activities within the system follow a statically computed schedule, that is, they are allocated time slots during which they can take place, and thus, by nature, these systems are predictable. So, to summarize the classification of embedded systems, we have embedded systems based on generation, based on complexity, based on performance and functional requirements, based on deterministic behavior, and based on triggering. So, under based on generation, we have first generation, second generation, third generation, fourth generation. Based on complexity, we have small scale, medium scale, large scale. Based on performance and functional requirements, we have standalone, real-time, networked, and mobile embedded systems. Based on deterministic behavior, we have hard real-time and soft real-time. And based on triggering, we have time-triggered and event-triggered. So these are the references. Thank you.